Hello and welcome to my video on building a recommendation engine with Python using pure Python and Pearson correlation. I won't be using any machine learning libraries. My name is Talat and today I will walk you through the process of creating a simple yet effective recommendation engine without relying on external machine learning libraries. So let's get started. And before we get started, you can switch on your closed caption on YouTube to follow the video better. So first of all, let's understand what recommendation engine is. A recommendation engine are systems that suggest items to users based on their preferences. They're widely used in various industries, from e-commerce to entertainment. And there are three main types of recommendation engine. The first is collaborative filtering, which is based on user interactions and behaviors. And then the second one is content-based filtering, which relies on the features of items themselves. And then there are hybrid methods, which combine both collaborative and content-based techniques. So in this video, we'll be focusing on building a collaborative filtering engine using Pearson correlation in pure Python. So what is collaborative filtering? Collaborative filtering is a recommendation system technique that suggests items to users based on the preferences of similar users. So if I want to recommend you something, I will find a user who is very similar to you, and then I will recommend items bought or liked by that user to you, which you haven't already bought or liked or watched. Now let's discuss the Pearson correlation coefficient. This is a coefficient that we'll use to find similarity between two users or two vectors. And this measures the linear relationship between two data sets. It ranges from -1 to 1, right? This R ranges from -1 to 1, where 1 means perfect correlation and -1 means a perfect negative correlation. And 0 means no correlation at all. So let me explain to you what's going on here. Later I'll give you a concrete numerical example to help you understand it a bit better, because this is the main formula that we'll be using in our Python program. So in the numerator, what is going on is that this x bar is the average of the first vector, right? And y is the average of the numbers in the second vector, right? So vector is basically, you can think of it like a series of numbers. Yeah. So let's say x is a vector 1, 3. It is a series of numbers. Its average is 1 plus 3 by 2, which is 2. So what it is doing is that it's taking the first number from the first vector, subtracting average of that vector, and then doing the same with the second vector and multiplying them together. And then we do the same thing with the second element, third element, and so on, and sum them together. So this is the numerator. In the denominator, what we're doing is we're taking the first element of the first vector, subtracting with the average, taking the square, and then doing the same with the second element and summing them up all together. And then we do the same with the second vector, and then we multiply them together and take the square root. So let's see how it plays out with actual numbers. So here you can see that for the sake of simplicity, I've taken the smallest possible vectors. It's 1, 3, and 2, 4. So we want to find the Pearson correlation factor. So the average of x is 1 plus 3 by 2 is 2, average of y is 2 plus 4 by 2 is 3, and then let's calculate the r. So in the numerator part, we are taking the first element, subtracting with the average, then taking the first element of y and subtracting with its average, multiplying them together, right? And then we are doing the same with the second elements. We are taking the second element of x, subtracting the average, taking the second element of y, subtracting with its average, and multiplying them together, and then adding the whole thing together, right? And then we do something similar with the denominator. We take the first element of x, subtract it with the average, square it, take the second element of x, subtract it with the average, square it, and sum them up together. And we do the same with y, and then we multiply these two factors and take the square root. And what we get is the following: the numerator is 1, the denominator is also, the numerator is 2 and the denominator is also 2, and we get the ratio as 1, which means that it has a perfect correlation. So let the coding begin. To begin with, we are going to import some of the libraries which are not machine learning libraries. I mean, they are used in machine learning, but as such, there is nothing out of the box that we can use as a proxy for our algorithm that we're actually using. So I'll be using pandas, numpy, and combinations so that I can combine different users. And these libraries you can pip install, or you can conda install as well if you're using conda. Okay, but I have already installed these libraries, so I don't need to install these libraries. So let's just check if everything is going fine. Do the usual name is equal to main thing, and let's just print a bunch of stars or a bunch of some symbols. Let's say at symbol, 40 at symbols, and let's just run the program. Python main.py, and first time it's going to take a little bit of time, and here we go. So all is working fine so far. And the next thing that we're going to do is we are going to make a function called Pearson similarity, and it's going to take two list or arrays or vectors, you can call them, user ratings 1 and 2, right? So the ratings that the user are going to give, it will be used as a proxy of how similar those users are. So this user rating, this one, it will be, let's say it is something like let's say this user had rated a movie, a bunch of movies, like 2 star, 1 star, 5 star, right? And then there is another user, he has also rated movies, those movies. Let's say he has rated 3, 4, 3, right? So based on these two vectors, we will find out how similar these two users are. So for the sake of this video, since we are focusing on actually implementing a recommendation system, we will just use a dummy data, right? So I'll just put the dummy data in the description of the video and also in GitHub repository. So this is basically just a dictionary, and then I'm going to convert this dictionary into a pandas data frame by the data frame method of panda, And just to see that everything is fine, let's just print this data frame. df.head, it will print the first 5 entries of the data frame. So let's run it and see how it fares. Python.main py. So as you can see that it has converted this dictionary into a data frame successfully. We have user ID, movie ID, and rating. And this is the basis on which we are going to make our recommendation system. So let us continue. So the first thing that we're going to do is we are going to convert the user ratings into array, NumPy array. So let's say arr1 is equal to np.array, then user ratings. One, and we will do the same for array2 as well. And then we are going to get the average is equal to np.mean arr1, and we will do the same for the second one as well. If you remember the numerator part, you will understand why I'm doing like this. So the numerator is 0, let's say. Denominator part 1 is 0, and denominator part 2 is also 0. Okay, and then what I'm going to do is I'm going to cycle through each element of the array and calculate all the terms in the numerator. Range len of array1, which is basically the same as the length of array2, and numerator plus is equal to arri minus average 1 into arr2 average 2. So let me just copy paste it. It's basically the same thing. Sorry, arr1 here, arr2 here, and average 2 here. So this is the numerator part. So now let's calculate the denominator. The denominator part 1 is arr1 I minus average 1 and whole square. We'll do the same for the second term in the denominator as well. And here we go. We have all the building blocks. Now we just have to check if any of the denominator is 0 or denominator 2 is equal to 0, then return 0. And if that is not the case, then we just return numerator by denominator 1 into denominator 2 raised to power of 0.5. So here we go. We have the Pearson similarity function already done. Now the next thing that we're going to do is we are going to create a similarity data frame, which means that we will have something like this. You can think of it like we will have a data frame where we have user ID in the first column, as the other user ID in the second column, and then the Pearson similarity index. So let's say we have a combination of user ID 1 and user ID 2, and maybe they have a similarity index of 0.3, right? And we might have user ID 1 and user ID 3. They might have a similarity index of 0. Let's say 5. And of course, the similarity index of user ID 1 with user ID 1 will be 1 because they're exactly the same users. So this is what we are going to do in this function that we're going to create a similarity data frame, and it is important to name the function correctly, which is appropriate to what it is doing. So we are creating a similarity data frame from the data frame that we get from here. Yeah. So let's. So the first thing we're going to do is we are going to do some cleanup. We're going to drop the timestamp column. I deliberately put the timestamp column over there so that you know that cleaning up is the first thing you do with the data. So columns is equal to timestamp. Okay. And then we can just print and see if this has actually worked, right? So over here, I'll just comment this out, and we're going to say print, or let's just run create similarity data frame, and we just give it df, the data frame that we had before, and then we are going to run it, and hopefully we won't be seeing the timestamp column. As you can see, we have user ID, movie ID, rating, but this timestamp column is gone. So now we have a clean set of data. So the next thing that we are going to do is we are going to create a pivot table with users as rows and movies as columns. So let's appropriately call this data frame as pivot data frame. Now let's call the pivot method. The index is going to be user ID. The columns are going to be movie ID, and the values is ratings. And then all the cells which don't have any value, just we'll fill them with 0. So let's just see if it indeed creates the desired pivot table as we intend it to be. So let's run it. There is a key error here in ratings. So it is not ratings, it is a rating actually. So now it should work. So wonderful, we have the movie IDs 1, 2, 3, 4, and 5, and user ID 1, 2, 3, 4, 5. And we have over here what is the rating a particular user ID gave to a particular movie ID. So user ID 3 gave a rating of 4 stars to movie ID 1, and so on and so forth. So this is excellent. We got our pivot table as we wanted. So what we're going to do next is we are going to create unique pairs of your user IDs. So because we want to compare each user with every other user. So generate all unique pairs of user IDs. So this helps in calculating the similarity for each pair. So user IDs is pivot table index, because we know that user IDs are the index of the pivot table, and we are going to have user pairs is equal to list combinations. As if you remember, we imported combinations from iter tools. It will give me all the combinations in a list. So all combinations of 2, right? And then let's see if our efforts have come to fruition. Let's run this and see if we get all the pairs. So as you can see here, we have all the pairs 1 2 1 3 1 4 1 5 2 3 2 4 2 5 3 4 3 5 and 4 5. So this also works very well. The next thing that we are going to do is we want to, for each pair of users, we want to extract their ratings, right? Extract ratings of each user, and then we are going to calculate the Pearson similarity. And then store the result in a list. So this is what we're going to do here. So we say similarity data, an empty list, and then we iterate through each of the user ID pairs, user ID 1, user ID 2 in user pairs. And then what we're going to do is we are going to say ratings 1 is equal to pivot restore df below C user ID 1 values. We are going to do the same for the second user, and we are going to say that the similarity is equal to Pearson similarity ratings 1 ratings 2. Right, once we have the similarity, we are going to append the value in the list with a dictionary, which is something like this, user ID 1. We are making a dictionary so that it will be useful for us when we are creating a data frame out of it. User ID 1, user ID 2, user ID 2, and then we have Pearson similarity is just similarity. Okay, and then once that is populated, we are simply going to say that similarity data frame is equal to pd.dataframe similarity data. Let's also print this, right? Let's print some pluses, and then print similarity df. Let's also return it. Right, all done. Let me comment this out, and then we simply run it. Okay, return is outside the function. All right, my indentation is all wrong, so let me indent it properly. Now it should be okay. So as you can see here that we have user IDs, pairs of user ID, and their pairs of similarity. So let's say if I want to recommend a movie to user ID 1. Then we see that with which user ID it has the highest Pearson similarity, and we can see that with 3 we have a Pearson similarity of 0.5, which is the highest. So what we're going to do is perhaps we are going to recommend the top 3 movies that user ID 2 has rated highly, which user ID 1 hasn't watched. So we can do something like that. So we have made the backbone of the recommendation engine, and then what remains to be done is getting data from actual data sources like a database or a stream, right? And then creating this similarity table, and then just processing the similarity table based on how similar two users are and recommending the movies. So this ends this particular video in which I have explained to you and shown you how to make similarity uh, table, and then after that it's just housekeeping. So in part 2 I will get into more real data sources, and I will actually recommend movies based on this similarity matrix that we have just made. So have fun, and then see you next time, and thank you for watching the video, and don't forget to subscribe and like, because I'll be posting a lot more videos now, so I want you to benefit from it. So see you next time.